For 40 years, I worked to protect people from health hazards. One of the most stubborn was heat stress. Why are we talking about heat stress today? Well, it's getting hot now. As a matter of fact, the hottest 29 days in recorded history all occurred in July of 2023. Indeed, July 6th was almost half a degree Fahrenheit, hotter than the previous hottest day in all of history. These high temperatures make people suffer. In 2022, almost 62,000 people died in Europe from excess heat. This figure shows that 3 times as many people die of heat in the US now as did 20 years ago. Heat consists of molecules moving quickly. Molecules move more slowly in cold matter. Heat can transfer through conduction, either within a solid or between two objects in contact. When molecules move rapidly in fluid, the fluid expands. That reduces the density of the fluid. Lighter, hotter fluid rises. The motion is called convection. It keeps delivering warmer fluid to the cooler surface. Heat can also transfer by means of infrared radiation. Every object broadcasts radiation, including us. Hotter objects broadcast more radiation and at shorter, more energetic wavelengths. Cooler objects broadcast less radiation and at longer, less energetic wavelengths. Because glass is transparent to shorter but not longer wavelengths, heat that gets inside of a glass object can get trapped there by the greenhouse effect. The picture shows the difference between two identical heat sensors, one in open air and another in a glass jar. You can see the greenhouse effect on cars parked in the sunshine. You can see how the temperature of this vehicle is almost 45 degrees hotter than the surrounding air. That's why we don't leave dogs or kids in sunny cars. The higher the temperature of a liquid, the more tendency molecules in the liquid have to leave the surface. The parameter we refer to that by is called vapor pressure. Liquids boil when the vapor pressure becomes equal to the atmospheric pressure, and emitted gas can just push the air aside. Because the molecules move more quickly, moving from a liquid to a gas consumes energy. That's why evaporation cools the liquid. Many of the cooling devices we use in workplaces are based on evaporation. Both of the objects you see are soaked in water before use. Condensation, in which molecules in a gas precipitate on the surface, conversely warms objects. You probably have had a subjective experience of condensation heating without noticing it. The air in this room now might be 70 degrees and 50% relative humidity. The water in it has a vapor pressure around 10 millimeters of mercury. Don't worry about the units, they're just units. When you inhale air, the lungs immediately raise the temperature to around 95 Fahrenheit and the moisture content to around 100% relative humidity. That expands the inhaled air by 4%. The evaporation cools you down. That expansion and cooling are both pleasant experiences. If you were outside on a day when the temperature was 105 degrees and the relative humidity was 100%, water would be at a vapor pressure of about 58 millimeters of mercury. The air would shrink by 2.5% after you breathed it, and the condensation in your lungs would actually heat you up. Both the shrinking and the warming are uncomfortable, and you might say it's too hot to breathe. The 4 factors that constitute your experience of heat are temperature, humidity, radiant heat, and air motion. The weather reporters on TV often report on the heat index or the feels-like temperature. Here is a calculator for determining that heat index. The index is based only on the air temperature and the humidity in the air. People in my profession evaluate heat stress using a parameter called the wet bulb globe temperature. I think it's a much more useful parameter for evaluating your heat stress. The wet bulb globe temperature incorporates the air temperature and the humidity as the heat index does, but also includes air velocity and the radiant heat load. Of course, no engineer can give a presentation without showing an equation. I promise you it won't be on the test. The reason I wanted you to see this equation is to show how important humidity and radiation are. The wet bulb globe temperature is equal to 1/10 of the air temperature, the one you normally use, plus 7/10 of the temperature on a stationary wet thermometer, plus 2/10 of the radiant temperature. That 7/10 underscores the idea that it's not the heat, it's the humidity. Do you remember that car I showed you where the radiant temperature was 45 degrees hotter than the air temperature? If the globe temperature is 1/5 of the Wibjit, that car would add 9 degrees to your experience of heat when you were driving. Most people blast the air conditioner when they get into a hot car. That does nothing for the radiant heat from the hot surfaces of the car. If you rinse the windshield and the dashboard of the car, you'll be greatly reducing a heat load. If you use one of those solar reflectors, you can cool down the dashboard, but the windshield will still be warm. You can just operate the windshield washer for a couple of seconds after you get in the car. Life consists of chemical reactions. Heat changes reaction rates differently. The same increase in temperature might increase the rate of one reaction by 50% and another by 200%. And you need to keep those reactions in balance to survive. Keeping this homeostasis, same place, is necessary to survival. The body will strive for homeostasis in a number of ways. Sweating and increased blood flow are chief among them. Both have high energy demands. The effort can exhaust you to the point where you experience fatigue, headache, dizziness, nausea, vomiting, and fainting. The body temperature is normal, but you can be too sick to walk. Even before you become sick or exhausted, heat decreases your strength and increases fatigue, depression, and anxiety. Your ability to make good decisions declines greatly, and accidents become much more frequent. If the body cannot protect itself from heat and the temperature rises in the body, heat stroke can result, and that can be fatal. For 5.5 years, I worked for the Occupational Safety and Health Administration. You know it as OSHA. Workers would call us every summer seeking protection from the dangers of heat. I was quite frustrated that I could offer no regulatory protection. I left OSHA 40 years ago. OSHA still has no heat stress standard. In July of this year, 110 members of the House of Representatives came together to demand that OSHA produce a heat stress standard. I can't tell you whether they will succeed. In response to the dangers of heat, many Texas cities produced regulations to make things easier on workers. The one in Houston was quite modest. It required that contractors give workers a 10-minute break every 4 hours when the temperature was high. Businesses hated this interference with private business so much that the Texas legislature passed a Death Star bill to prohibit local jurisdiction of workplace conditions. A judge in Houston found this bill unconstitutional just last winter. Outside the window of this building, you can see an area with loose dirt, trees, bushes, and grass. Evaporation occurs from the plants. Rural environments have many surfaces that dissipate or protect us from heat. In urban settings, there's a lot less vegetation. An asphalt, brick, or concrete surface can be 45 degrees hotter on a sunny day than equivalent grassy surface. This occurs even without shade from trees. Falling on a Phoenix sidewalk last month could cause third-degree burns. Concrete and asphalt surfaces in urban settings can concentrate so much heat that we call cities heat islands. This map shows that on a sunny day, downtown Philadelphia can be 9 degrees hotter than a nearby rural area. Note that the map shows air temperature without regard to the radiant heat we've been talking about. Remember what I told you about the greenhouse effect? Carbon dioxide, methane, and water vapor, and some other gases absorb long-wave radiation and re-radiate back to the surface of the Earth, just like glass does. That, of course, warms. Ambient temperatures have already risen 2 degrees Fahrenheit from the temperatures recorded in the 19th century. The average temperature is predicted to rise another 4 to 7 degrees Fahrenheit by 2100. Temperatures will not rise evenly. As you can see from this map, the Arctic is expected to heat more than other parts of the world. That matters, of course, because the Arctic and Greenland harbor lots of ice. What will happen as the world warms up? Glaciers and ice caps will melt. Sea levels will rise. Water will cover farms, agricultural areas, coastal cities, and even entire countries. People will starve. Some animal species will disappear. Extreme weather events like heat waves, droughts, wildfires, hurricanes, and tornadoes will become much more common. How long have we known this is coming? Well, in 1824, French mathematician Joseph Fourier warned us that the gases in the atmosphere would create a greenhouse effect. And in 1938, British engineer Guy Callender tied that global warming directly to fossil fuel use. Now, how long has the fossil fuel industry known this calamity is coming? In 1977, scientists working for Exxon developed a greenhouse effect model that showed that fossil fuel emissions would lead to about 1/3 of a degree Fahrenheit of warming every 10 years. Their predictions have proved to be eerily accurate. Okay, so what did the fossil fuel industry tell us about global warming? In 2013, Exxon Chief Executive Officer Rex Tillerson said, "There are uncertainties about climate change, especially what the principal drivers of climate change are. Their overt statements may have moderated, but they still strive to keep real conservation out of regulations and international treaties." So how common is that language among Americans? In 2022, only 54% of US adults thought that climate change was a major threat. Among Republicans, that fraction was 23%. There's a whole lot of people who still need convincing. What do I want you to do? To protect yourself, drink water and avoid the sun. To protect your neighborhood, plant trees and shrubs. To protect workers, demand an OSHA heat stress standard and support unions. To protect the world, install solar panels, advocate for wind power, and drive electric vehicles. Of course, I believe in taking political action. There's a demonstration in New York City on September the 17th to demand a switch from fossil fuel to renewable energy. The Unitarian Universalists for Just Economic Community, an organization I serve with, is sponsoring a conference on the Farm Bill and climate change. Please consider attending. Thank you for your time. Let us work together.